Welcome to EDU World Space.
Okay, so for this one we have light and velocity curves of an eclipsing spectroscopic binary star system. We have an orbital period and maximum radial velocities of stars A and B. We also know the time between contact and minimum light, and the length of primary minimum. We also know the apparent bolometric magnitudes of the maximum, primary minimum, and secondary minimum. And from all of that information, assuming circular orbits, we're going to find some different things. And the first thing is we want to look at or find the ratio of stellar masses. Okay, well, there's an equation in the book that says m1 over m2 equals v2r over v1r. And so all that we have to do is use this equation and directly plug it in to get that mb over ma equals va over vb. Plug in our values that are given, and we get an answer of 0.241. So that one's not too hard. All right, what about b? We want to find the sum of the masses. Okay, well, there's an equation in the book that says that the sum of masses m1 and m2 equal p divided by 2 pi g v1r plus v2r over sine cubed I, and all of this is cubed up there. So we get that ma plus mb equals p over 2 pi g times va plus vb cubed over sine cubed I. So we literally just plug in the values that are given, and we know that we have our constants, and I get an answer of about 5.13 times the mass of the sun. Okay? Part C is pretty easy, because now I have a ratio, ma to mb, or mb, to ma, equal to 0.241, and I have that ma plus mb equals 5.13 mass of the sun. So I have two equations, two unknowns, and I can find the individual masses. And when I do that, I get that ma equals 4.13 mass of the sun, and mb equals 1.00 mass of the sun. Okay. Now, for the next one. D. We want to find the individual radii. Well, remember that we have the equations Rs equals VA plus VB over 2 times TB minus TA. Plug in our values, and I get about 1.00 times the radius of the sun. And we have another formula that says RL equals RS plus VA plus VB over 2 times TC minus TB. Plug in your values, and you get an answer of about 2.11 R of the sun. And then finally, for part E, we want to find the ratio of the effective temperatures of the two stars. Remember that you can find brightness ratios from an equation in, I think it's like chapter 3. That's at least the one that I'm using. And for primary and secondary ellipses, I get that BP over B0 equals 0.0302, and BS over B0 equals 0.964. Now, in order to get the answer of the effective temperatures, we need to use an equation in chapter 7, 7.11. Using that equation, it says that TS to TL equals 1 minus BP over B0 divided by 1 minus BS to B0 to the 1/4 power. Plug in your numbers, and you get an answer of about 2.28.